Welcome back. I wanted to make a quick video explaining why these temperatures exist, why these range of values exist, why do the formulas look like this. Mainly I wanted to explain why uh, why the formulas have the numbers that they do. Because I want you to be able to see the formulas and apply them and see why they matter. Because you are going to be limited as engineers if you cannot convert Fahrenheit to Celsius or Celsius to Kelvin quickly, if you have to rely on Google to do that math. If you can't look at the formula and do it yourself, you're never going to be as good of an engineer as you can be. So let's look at these. So to go from 32 degrees Fahrenheit to 212 degrees Fahrenheit, that's freezing to boiling. That is a range of 180 degrees. So it goes 180 degrees upward. Now over here, we go from 0 to 100. Well, that's clearly a range of 100 degrees. So let's go ahead and write range and range. Okay? So with this in mind, what is this? Okay. Well, first off, clearly the freezing point from here to here is 32 degrees higher. So there's plus 32. So to go from Celsius to Fahrenheit, I got to add 32 to Celsius to get to Fahrenheit. Okay? Now, what about this 9 over 5? Where is that coming from? Well, if you look at the range, it goes 100 degrees up here. It goes 180 degrees up here. Well, that is just a ratio, 180 over 100. Well, that equals 1.8. Well, where does this 9 over 5 come from? Well, if you just type that into your calculator, 9 over 5, what you'll get is 1.8. So we can kind of see how this is 1.8 times Celsius, or 9 over 5 times this. So that's where this formula comes from. And with that, we can prove this formula, so you don't have to memorize it, you don't have to look it up, you can prove it as you go. But this is why the formula is what it is, and it's incredibly simple. And then if you want to go the other way, you just flip everything. You just make it minus, and you make it 5 over 9 instead of 9 over 5, which is the exact opposite. Okay, and what about going to Kelvin? Okay, well, to get to Kelvin, the formula is very simple. You simply add 273, and more specifically, it's 273.15, 0.15 here. Same thing here. And so why? Well, the reason why is because absolute zero is well, it's this hypothetical situation where there's no movement, there's no molecules moving around. It's completely frozen. You cannot get any lower than absolute zero. Well, if you measure that in Celsius, what that would be is negative 273.15 degrees Celsius. So it's 273.15 degrees below zero is absolute zero. Well, what we said was Kelvin at zero equals, let's rewrite that. Kelvin at zero equals negative 273.15. So now you can kind of see, well, that's why you have to add 273.15 to Celsius to get Kelvin. And so again, it's important to understand this, because if you don't understand simply how to convert temperature, then you're never going to be that good of an engineer. You're never going to be good in the field of science at all. This is such a simple unit measurement that you could easily prove yourself.